Thank you, everybody, for being here today. My name is Dr. Regina Tuma, and I am core faculty in the doctoral program in media psychology. And I'm very happy that I was invited along with Dorothy Andrews to discuss with you the relationship between big data and psychology. Just by way of a little background, I became interested in this area, I would say about 4 years ago. And the way I came into it is, again, I have a PhD in psychology. I'm not a computer analyst, but I became interested in this because I saw the power and influence of data analytics, and so I became interested in how people were talking about it. I became interested in the analytic sequence, and I started to see something that I really couldn't share with a lot of people because it's like when you have an idea and you kind of don't know how to talk about it because not a lot of people have been working on this. And what I saw is that there was a kind of relationship between psychology and big data, but nobody was talking about it. And so at that point, I did what Fielding does best. And what Fielding does best is that when faculty members have ideas, we have the ability to explore them and to follow up with them. And so I created, I think that it was the first graduate course in exploring the relationship between psychology and big data. So here we are about 4 years later. It has been a journey, and I am very excited to present what I hope will be an area that many psychologists will be interested in. And as you'll see later, I'll discuss even many practitioners in the data analytic field. So thank you for being here. All right, next slide. So I'm going to actually start by talking a little bit about what is big data. This is actually a word cloud that was from a blogger, technology blogger, who had actually done a very interesting report. It was back in 2014 when I was trying to search for all of this and looking for information. And she had actually asked people, CEOs, people in tech, what big data was about. But this is really before we see a kind of migration out into the broader public. So next slide. So if we actually had to look at big data and actually talk about what is big data, I think that what we would see is that most people would say, oh, big data is a method. That is, and what we hear is, oh, it must be good. There are lots of numbers. Some people will say, well, you know what? It's predictive. It can predict behavior. Some people will say, will mention algorithms, right? Well, it's a formula that can model reality. Some people, when you talk to them about big data, will talk about, well, it's artificial intelligence, it's machine learning, it's automatic learning, and it can rival or has the potential to surpass human intelligence. And then we'll also see some people referring to data visualization, which is, cool maps that allow for exploration of data and or can communicate data trends. Next. Okay, but as big data is a method, and so there is an epistemology that is attached to big data. One way of thinking about big data is that it is a method of knowledge production. In the same way that we have research methods and various ways of researching things in the sciences and social sciences, big data is a method of knowledge production. But it's not the first time that we're going to see that there are certain things that are attached to this method. And so, for example, most people will say, well, it's a superior method, right? In the same way that you will hear, well, an fMRI is a superior method of of studying the brain, right? So attached to big data is this idea that it's a superior method. It is granular, that is, that you can zero in on specific aspects and corners of reality. Some people will also say that we'll see it as a form of digital positivism. That is, that it's like it's tapping into reality, right? It's tapping into the real thing. And something else that is attached to it is this idea that the numbers will speak for themselves, right? There is no need to theorize. This goes back to Chris Anderson's famous article that basically talked about the end of theory. And so what that means is that there is an automatic objectivity that is attached to big data. And people, even in companies and corporations, will talk about how we need to do data-driven decisions. Because as you see here in number 5, the view is that by having the numbers speak for themselves, it will bypass human error. Okay, next. And I think that if we look at our world today, one of the things that we could really talk about is the fact that data, big data, right, are generalized everywhere. Big data is everywhere. It is used to make decisions about everything in our lives. And in some sense, we may not even be aware that algorithms are being used to make decisions about our lives. And so, for example, in government and public sector, we see a lot of people using big data, such as in the administration of welfare services. For example, you'll have algorithms that automatically can codify people and say, yes, this person would qualify, this person will not. You have a lot of governments now engaging in smart city initiatives. Notice smart city, and that is where you can gain feedback from your constituents, and you can report, oh, there's a pothole here, oh, something's going on here. We also see these invisible algorithms that are churning in terms of areas like finance. You apply for a mortgage, insurance. All of these things are now being done through algorithms that automatically can sort people. We see this in education, and we see a lot of people loving this because it's education through technology, right? Giving students all of these standardized tests, and now this can really get at learning. This can really get at how teachers are teaching. It's called the data-driven movement in education, and it's responsible for now, instead of having someone evaluate a teacher, these algorithms can evaluate teachers and student success. You might have heard of predictive policing, and so a lot of these algorithms are now being used in criminal justice, so applied in neighborhoods to predict where crimes are going to occur. And we also see the numbers being churned and given to, for example, to a trial at the point of sentencing. And so we see these algorithms now that will determine who can possibly, have a, who can possibly commit a crime again, and so what's the profile? And then we really see this used, and I heard someone the other day say that it really needs to be looked at even more in terms of HR and management, right? So a lot of employee hiring, a lot of employee evaluations are now being done through big data analytics, collecting numbers, right? Machine learning, and coming up with an algorithm that is said can then evaluate employees. Okay, next slide, Dorothy. But I really like this quote from Eilish and Boyd, and from their great article, Situating Methods in the Magic of Big Data and AI. And this quote really says it all for me. Through the manufacturing of hype and promise, the business community, and I would add in there as I did, technology sector, has helped produce a rhetoric around these technologies that extends far past the current methodological capabilities. So in some sense, we are, through faith, really attaching a lot to big data analytics as a process that may not be there. Next slide, please. And so it's not surprising that now there is what I like to call a second generation of literature that is emerging, and that is as big data analytics, the process has been generalized across all these different areas, where we see that they're documenting systemic biases across many of these areas. So, for example, we now see systemic biases across race and gender in something as, you might not think about it, but in targeted ads on something like a Google search, all right? We see a lot of systemic biases in facial recognition algorithms. Bulamwini and Jebru did that research, and it's quite interesting that the algorithms can detect white faces, but not clearly detect black faces. We see a lot of this is used in mortgages, and so what we're seeing is a continuation of mortgage redlining in terms of who or which groups are given mortgages, and same thing in insurance pricing in terms of differential pricing. We also see biases in teacher evaluations. We see biases in hiring and management. And I was listening to something the other day, and they were talking about how there's this study that was conducted where there was an algorithm that was simply just excluding women, and the data scientists didn't even know that that's what they had created. Now, remember, what is happening is that all of these things are being employed in our society. And again, and then we go to predictive policing and sentencing algorithms. And there was some great, I think it was ProPublica that did the article, and I cited here Angwin in 2016, where they showed the difference in just showing a white face and a black face. And all of a sudden you see that the white gets lower sentencing score, and the blackface, it's differential, and so it is discriminating. Okay, next slide. And so there's I have a quote here from Ruha Benjamin, who wrote this great book called Race After Technology. And so she's looking at all of this. She's actually a sociologist, I think at Princeton. And she's looking at this and she says, it's almost as if our biases are coded into our technological DNA. And so she says, technologies which often pose as objective, scientific, and progressive, too often reinforce racism and other forms of inequities. Next. And so this is where really my entire work for the last couple of years is leading up to. And that is the importance of psychologists to get involved in and engage big data analytics in a debate in terms of what is going on. What has yet to be addressed, and we're getting a literature that talks about systemic biases across, but missing from all of that engagement really are the voices of psychologists. And yet what we find in the big data analytics sequence is that there are a lot of assumptions that are built into this data analytics process that concern the psychology of thinking. So for example, psychologists, we came up with the idea of human cognition as information processing, right? And so that you're gonna see that's one of the assumptions in data analytics. We know, we are experts in discussing attributional errors in sense making. That is, when we look out into the world, what kind of mistakes and biases do we bring with us? We're also the ones that gave the world the whole idea of unconscious biases, right, and stereotypes, and we discuss these things. And we also tend to look in sort of modern cognitive psychology, we tend to look at thinking as a kind of scripted algorithm that is just automatically on a loop. These ideas are coming from us as psychologists, right? And we are giving inherent in the data analytic process, right, are these assumptions about what is psychology or things that we know about as psychologists. And then I'm going to say psychology and the computational model of mind. You know, I think it's important to recognize that we gave computer scientists this view of the computational model of mind. And indeed, it was psychologists' reliance on computers as a way of modeling cognitive information processes and modeling human thinking that computational model is the core assumption that animates machine learning, artificial intelligence, and it actually makes the analytic sequence possible. And I'm also going to say that if we take a look at psychology and its development as a field, right, we could say that before there was a data analytic sequence, psychology was the first predictive science. And our predictive science was in the form of behaviorism and its ability to predict behavior. So before we ever had an analytic big data sequence, we had psychology was a predictive science on its own through its embrace of behaviorism. Right. Next, so what I'm going to show you here in this slide is how you can really map onto the big data analytic sequence, right, topics in psychology. All right. And the reason why I'm doing this and saying this is because we need to get involved in this conversation. And we need to deepen, again, in the analytic sequence. There is a lot, right, of assumptions about what thinking is. And so, for example, you take a look at the analytic sequence. Well, part of the analytic sequence is making choices, data selection, coding, right? Merging databases. Well, as psychologists, we have really studied the psychology of categorization. So by bringing our voices here, we can say, here's where you have to be careful. What are you really doing when you categorize, right? To what extent is a category immutable? And to what extent is it something that we create and is kind of fuzzy? Psychologists have been talking about categorization. We have the literature to really discuss this and to deepen and contextualize what big data analysts are doing. We have the data analyst. Well, we can look at the data analyst, the person who is either feeding the data, training the algorithm, or even beginning to just code and make choices. Well, that data analyst is what we call in the psychology of attribution, they're the observer. They are observing, and we know that when we observe, we have a psychology of attribution and bias. We have these quick methods of categorizing people, right? And so, again, we can bring this literature to bear in the analytic sequence. When we talk about predictive analytics, I said that, behaviorism was really the first predictive analytics, but we can also talk about the psychology of personality, right? We say in the psychology of personality that based upon your traits, we can more or less see certain behaviors or certain types of actions, right? Well, if you actually take a look at that literature, we can really inform this analytic sequence because we know that there are different conceptualizations and different questions that we can ask in terms of what is a personality, what is a trait, how much of it is really something that you can't predict. Again, the voices of psychologists are needed in this discussion. When we talk about, the impact of numbers, big data runs on numbers. The numbers are the things that the analysts themselves deal with, but it's also what the public will see. Well, what do we mean by that? And what does it mean when we deal with numbers from an information processing perspective? Psychologists can add a lot to this discussion. What about visualization? That is those maps that you see. Well, at this point, we'd have to talk about the psychology of visual perception, because we know that what you see is not necessarily just what's on the page, but it's also what we bring to it. And so that is something that needs to be taken into account by data analysts. And then we can also talk about what about the applied impact of data decisions on communities, right? And here we can talk about social influence and decision making. How do communities react when data, these decisions come from above, for example? Surveillance and privacy. Big data runs on surveillance. We can ask questions of privacy. But again, and it's related to the one I just mentioned, what happens when you surveil a population? And to what extent do people, as thinking participants in their lives, start to act in a different way? And so they react to what the data analysts are sort of saying and predicting. And so you can't just assume that the population is passive. They're going to be changing. That affects the results. And then one of the things I think that we see in all of this is that there is a fulcrum here that goes through racism and stereotyping. And so I think it would be very good to also situate this from a social justice perspective, right? Which, by the way, it applies to all of psychology in general, but having a discussion about critical psychology of race. So again, I just want to say something to you. You don't have to be a computer scientist to get into this. What my focus here is on how psychologists can join this debate. And I think I'll show it to you in the next slide. So wanted, we need lots of psychologists to help basically further this field. And we need psychologists who can apply these skills and knowledge. And so I think that this would be highly relevant to a couple of people. And now I'm going to mention one where I don't, here, I think that people interested in this field, right, learning the psychology component of it, right, this would be highly relevant to computer scientists, data analysts, practitioners in various fields where data analytic is now applied, such as that earlier slide, right, the public sector, government, law enforcement, data, law, and education. And so you could see how psychologists could come in as part of this discussion. Psychologists as part of multidisciplinary teams in tech fields that use big data, right? So psychologists here would be able to come in, provide expertise both at the point of creation of algorithms and how best to model a process, and also at the end, where how do you interpret these results? Where could they be valid? Where can they not be valid? All right. There could be lots of, I think any psychologist who has these skills could really apply it at the corporate level. One of the things that we do know, and I know from my own students fielding, is how much big data is part of their work environment. And a lot of them are managers, and a lot of them have to deal with the numbers. So the question is, psychologists can come in. I think they can help decision makers, right, understand the process, where this could work, where there could be reactance, where it can hold, where it cannot hold, right? And contextualize the results before decisions and policies are made. And I think it would be important to have this level of discussion in any sector in terms of how data decisions, right, will impact communities. And so we could have different research skills, not computer analytic skills, but bringing in good old qualitative methods that can help people understand how data will impact a community. Okay, next slide. And this is a good segue because now I'm going to introduce our student and practitioner in this field, Dorothy Andrews. Dorothy is a PhD student. She is working with me in this area, and she is my dream student because she really comes from, she's a practitioner, right, in data analytics, and she sees the need for this. And so I can tell you we have lots of interesting conversations, and so it is my honor to present Dorothy to you, who will talk about how she's using this.
Okay, let me start by saying thank you to Regina for her insightful presentation. And I want to thank the fielding community for this opportunity to provide a glimpse into my research on how big data and algorithms are impacting our perception of risk and our ability to become self-determined as a function of privilege. I am also happy to share some of my business insights as to why this topic is important for professionals designing big data and algorithm-based human transaction models, and for those affected by those models. So Regina discussed some impacts of big data, and this depiction reflects 7 V's, but there are many more. Big data is no longer just about volume. Katie Nuggets, a data science organization, has identified 42 V's that have been adopted to describe big data since 2001, when there were only 3 V's: volume, velocity, and variety. Variety is an especially important big V in my line of work as an actuary and data scientist, because insurance algorithms are increasingly leveraging non-traditional insurance data to understand the behavioral makeup of potential insurers. An emerging issue with a lot of non-traditional insurance data is that there is no regulatory oversight over its veracity or ethical construction. The virility of big data has made us all aware of how quickly it can crowdsource reactions, promoting justice by social media. The speed with which big data can spread and be shared has the power, as we have seen, to transform bad behavior into positive public service. Studying media psychology has helped me to understand how mediated our lives have become because of algorithms. They are everywhere. Dr. Shirley Turkle of MIT is known to have said, "Technology does not just change what we do, it changes who we are." This statement reminds us that we have to be mindful and watchful of the behavioral effects of technology to shape the data we study and the models built upon that data. Not all algorithms are bad. In fact, they are responsible for a lot of labor-saving technology. But when there is a lack of transparency and only a select few understand their underlying mathematics, we can become unwitting subjects to their effects and become powerless to subvert them. These notions lie at the heart of my research. Big data and algorithms are agents of influence in major aspects of our lives: housing, policing, criminal justice, employment, healthcare, and education, with disproportionate and often adverse effects on disenfranchised segments of our population. In criminal justice, the Compass algorithm that predicts recidivism rates adversely affects people of color. Insurance and credit scoring algorithms have similar disproportionate adverse effects. Wearables are generating new data for health management, but some of the technology does not work as well on dark skin as it does on lighter skin. Some health algorithms have been found to produce similar flawed outcomes. When algorithmic outcomes are flawed and biased, it has been found that either the training data is biased or the modeling team lacks diversity, or both. The first source of bias is easier to fix than the second, although evidence is emerging that removing biases from historical data may not be completely possible. Finally, decision tree algorithms like the ID3 algorithm, which stands for Iterative Dichotomizer 3, are being used for sifting and sorting, weeding out the wheat from the chaff in a supposedly unbiased and algorithmically fair approach. Just think, we are trying to algorithmize fairness, which is a difficult construct to even define. We have been blindly and erroneously led to believe algorithms are fair. Excuse me. My hypothesis is that algorithms have the power to undermine our autonomy, impair our ability to be self-determined, and alter our perception of risk with and without our conscious awareness. Virginia Eubanks in Automating Inequality talks about how algorithms are not more fair and more unbiased than human-driven decision-making processes. In fact, she suggests they are worse because they are allowed to function with little human oversight and intervention to supplant human decision-making in a quest to fuel a data-driven approach. When algorithmic results are counterintuitive, they are rationalized as true rather than challenged as being wrong. This is problematic once algorithms are productionized to fuel dashboards for decision-making, because it becomes nearly impossible in some instances to reverse engineer their damaging effects on the lives of real people. Those tasked with implementing the prescribed actions of algorithms often do not understand the inner workings of the underlying mathematics and are defenseless in addressing underlying reasons for an adverse decision. While those subject to algorithmic decision-making are compelled to relinquish personal data and some level of autonomy to receive contingent benefits. But if you have privilege, you can circumvent relinquishing autonomy and personal data. Algorithms need to be more human-centered to enable autonomy rather than disable it, and improve our perceptions of risk to facilitate the optimal management of threats to our personal well-being. We naturally want to ask, how does one measure risk perception? Dr. Sander van der Linden of the University of Cambridge came up with a risk perception model to explain risk perception through the integration of 4 core dimensions of risk: cognitive factors, experiential factors, sociocultural factors, and social demographics. The model was originally conceived to explain risk perception relative to climate change, but has recently been adapted to explain coronavirus risk perceptions. These dimensions should make intuitive sense. My research is focused on examining the effect of algorithms to moderate our perception of risk along these dimensions. To conclude, big data and algorithms facilitate discrimination by proxy. In insurance, using certain variables like race are avoided in determining insurance rates. In fact, insurance companies do not collect race, but are not federally prohibited from doing so. States set most of the laws and regulations governing insurance company operations, but most insurance companies do not collect race on the insurance application to avoid being accused of race-based discriminatory insurance pricing practices. However, the advent of big data contains many variables that are highly correlated with race, and they have the same effect in pricing algorithms based on race. For example, zip code, education, income, and even surname are common proxies for race. In many states, education and income are strictly forbidden by law, and any variable that poses a risk of unfair discrimination in pricing is not allowed at the regulator's discretion. Proxy discrimination is gaining a lot of attention by insurance regulators because third-party data is becoming really good at designing variables that mask discriminatory effects. So I hope you enjoyed hearing about my research and how it applies to my work as an actuary and data scientist. Regina and I would like to invite you to ask any questions you may have at this time.